Hello friends, welcome to our channel EduUdr. I am Garima. I will teach you biochemistry. In this video, I will continue my lecture on protein. Today we will discuss very important concepts. These are pi value, pKa value, protonation, deprotonation, and at last charges on individual amino acids. First, what is the pi value? There are 20 protogenic amino acids present in the nature. Out of these 20 amino acid has alpha carboxylic group, alpha amino group and side chain. But out of these 20, only 7 amino acids has ionizable side groups. These are arginine, aspartate, cysteine, glutamate, histidine, lysine and tyrosine. Except this, all 13 amino acid has non-ionizable side groups. When these amino acids are run in the electric field, they will move either toward the cathode or toward the anode. That is depending on the charge that they are carrying. But meanwhile in the cathode and anode, there is some pH value at which the amino acid get be stuck. They will not move further. Why they will not move further? Because at this pH value, the amino acid has the net charge of 0. The positive charge of the amino group and the negative charge of the carboxylic group get be cancelled out, so that the pH value at which the net charge is 0 is known as isoelectric point. This isoelectric point or pi value is very useful for isolation and purification of different amino acids and protein. Next, what is the pKa value? pKa value is the acid dissociation constant. When the amino acid present in the aqueous solution, they will either donate a proton or they will receive a proton. So this tendency of donating a proton or receiving a proton described with the help of pKa value. This Ka value deals with the acid and pKb deals with the base. This pKa value is very useful to compare the strength of different amino acid. As the lower will be the pKa value, the stronger will be the acid. Each alpha amino group, alpha carboxylic group, R side chain has a specific pKa value. pKa value means at a pH value, they will start to donate the proton or to receive the proton. So that's very necessary to memorize this pKa value. You can go through any reference book such as Laryngococcus. The next very important concept is protonation and deprotonation. What is the meaning of deprotonation? D means removal. Removal of proton is the deprotonation. Then what will be the protonation? That is the addition of proton. Each amino acid contain alpha amino and alpha carboxylic group. Both these alpha amino group and alpha carboxylic group will either donate a proton or receive a proton. When they will donate a proton, they will act as an acid, and when they will receive a proton, then they will act as a base. But this behavior of acceptance and giving the proton depending on the pH value. This concept of protonation and deprotonation can be easily cleared by using the titration curve. In this lecture, I am using the glycine titration curve as a reference to define what is the protonation and deprotonation. When there is at a very low pH value, what will be the abundant amount in the surrounding? That is H plus ion, mean hydrogen ion present in the surrounding in the sufficient amount. Because there is sufficient amount in the hydrogen ion, then what will be the condition of the amino acid in this way? The both amino group and carboxylic group will receive the proton, mean they will act as the strong base. So at a very low pH, the amino acid act as the strong base. Because they act as a base, then they will both receive the proton. They will both group, carboxylic group and amino group present in the protonated form. As the titration is proceed, the number of H ion get be decreased and the number of OH ion get be increased. Because the pKa value of the carboxylic group is low, mean 2.3 up to the reaching the pH value of 2.3, there is a phase. There is an equal molar proportion of the deprotonated form of carboxylic group and protonated form of carboxylic group of amino acid. After proceeding the titration, there will be the completely deprotonation of carboxylic group will be occurred. It is reaching up to the 5.97, the deprotonation of the carboxylic group get be completed and the deprotonation of the amino group get be started. Why the carboxylic group will be deprotonated first in comparison to amino group? Because the pKa value or acid dissociation constant of carboxylic group is lower, is 2.3 in comparison to the amino group. At reaching up to the pH value, there is an equimolar proportion of the deprotonated form of amino acid equal to the protonated form of amino acid. Then what will be the net charge in this phase? There is a +1 on amino group and -1 on carboxylic group. So what will be the net charge? That will 0. So the pH value at which the net charge on amino acid is 0 is called as isoelectric point. On proceeding further in the titration, the deprotonation of the amino group get be started. Up to the reaching of the pH value 9.8, that is the pKa value of the amino group, the deprotonation of the amino group get be started. So that there is an equimolar proportion of the deprotonation form and protonation form of amino group of amino acids. After proceeding and reaching up to the 12 pH, the amount of deprotonated form present in the abundant amount. What does that mean? Because at the low pH there is sufficient amount of hydrogen ion, but at the high pH there is sufficient amount of hydroxyl ion. To satisfy this charge, the proton of carboxyl group and proton of nitrogen group is given to their surrounding, so that the amino group get be completely deprotonated. What's mean it? At a very low pH, when the pH value is less than the pKa value, then all amino acids present in the protonation form. When the pH value is equal to the pKa value, then both protonated form and deprotonated form present in the equimolar proportion. But on proceeding further, when the pH value is more than the pKa value, then all amino acid will be present in the deprotonation form. Then what will be the net charge on these amino acids? When at a low pH value, all the amino acids present in the protonated form, amino group has an extra proton, and so that they will carry a +1 charge. What will be the net charge in that phase? That is +1 charge. On proceeding further in the deuterionic form, what will be the net charge? That will be 0, because plus charge and minus charge get be cancelled out. On proceeding further and reaching up to the pH value of 9.8, what will be the net charge? Or at a high pH value, all amino acid present in the deprotonated form. So what will be the net charge? That is -1. Okay. Then what will be the Pi value? Pi value in that phase is the average of both pK1 and pK2 value. There is one more concept, the buffer zone. That buffer zone is the zone surrounding to the 2.34 or pK1 value and pK2 value. That is a +1 value or -1 value of these values. What is the buffer zone? Buffer zone is the area there is very less increase in the pH value while adding the base in the solution. This titration is very useful to identify the pKa value of different ionizing group, identify the reason of buffering for amino acid, determine the charges on the amino acids, and last, determine the Pi value of amino acid. The last concept, determine the charges on individual amino acids. There are two phases in this way. One, when the R side chain is non-ionizable, and when the R side chain is ionizable. When the R side chain is ionizable, there is two conditions is possible. Whether they will carry the positive charge or they are basic in their behavior, or they will carry the negative charge or they acidic in their behavior. If the side chain is non-ionizable, I am using the glycine as a reference to clear this concept. In the glycine, the alpha carboxylic group pK value is 3.34 and alpha amino group pK value is 9.6 because there is no ionizable side chain, so that there is no additional pK value. When titration is proceed up to the reaching of 2.34, that is the pK value of 2.34 of the carboxylic group, the deprotonation of the carboxylic group get be started. Okay, so that when this is proceed, the reach up to the pH value when the net charge on the amino acid get be cancelled out. So that the net charge will be amino acid in this way, that is 0. After reaching up to the pH value of 9.6, that is a pK value of 9 points of amino group. The amino group deprotonation get be started, so that at a very high pH value, both amino group and carboxylic group get be deprotonated form. In the deprotonated form, the amino group carry no charge, but the carboxylic group carry -1 charge. Well, then what will be the net charge in this way? That is -1. So what is the Pi value? Pi value is the pKa value on pK2 by 2. That's the average of both pK value. So that the Pi value of the glycine will be 5.97. That is the pH value at which the net charge on the amino acid is 0. Next, if the side chain is ionizable and acidic, such as case of the aspartate and glutamate. I used aspartate as a reference. In the aspartate, there are 2 carboxylic group. One in the alpha carboxylic group and another present in the R side chain. Both carboxylic group has different pK value. That is because of presence at the different positions. The pKa value of the alpha carboxylic group is 1.88 and the pK value of the R carboxylic group is equal to 3.6. So that first the alpha carboxylic group get be deprotonated first. After proceeding the titration and reaching up to the pH value of 1.88, first the alpha carboxylic group get be deprotonated. In the second structure, so what will be the net charge? The +1 charge on the amino group and -1 charge on the carboxylic group. At a very low pH value, there is fully protonated form. Okay, so what will be the net charge in the second structure? That is equal to 0. That is a deuterionic form. On proceeding further, the titration, reaching up to the pH value of 3.8, the deprotonation of the R carboxylic group get be started. So now what will be the net charge? There are -1 equal to -2 and +1 on the amino group. So what will be the net charge? It is equal to -1. On proceeding further and reaching up to the 9.6 pH value, the deprotonation of the amino group get be started. So what will be the net charge at the high pH value? That is equal to -1 on both carboxylic group. So it is equal to -2. In that phase, when there are more than 2 pK value, which pK value is considered to determine the Pi value? That is the question. Only those pK value is considered to determine the Pi value which is surrounding the deuterionic form. In this example, the second one is the deuterionic form. So we will consider only 2 pK value, that is pK1 and pKr. So that the Pi value for aspartate will be 2.77. Next, if the side chain is basic in their behavior, they will carry the positive charge. Here lysine is used as a reference. It will contain 2 amino group, one at alpha position and another in the R side chain. Both amino group has a different pK value. The alpha amino group has the pK value of 8.96 and the R side chain amino group has the pK value of 10.53 because it is distant from the carboxylic group. So it has the different pK values. First, before at the very low pH, the amino acid present in the fully protonated form. Then what will be the charge? It is +1 on amino group and +1 on the R side chain amino group, that is equal to +2. After reaching up to the pH 2.18, the carboxylic group get be deprotonated. In this phase, the net charge will be -1 on amino group, so that it will net charge will be +1. After reaching up to the pH value of 8.96, the alpha amino group get be deprotonated. So in this case, the net charge will be 0, mean only -1 charge on the alpha carboxylic group and +1 charge on R side chain. On proceeding further, at the pH 10.5, the amino group of R side chain get be deprotonated. So at a very high pH value, the net charge, the whole amino acid present in the deprotonated form. So the net charge on the amino acid in this way, it is -1. Here, which pi value is considered to determine 2 pi value? There are 2 pK value that is surrounding the deuterionic form, that is pK2 and pKr. So the pi value of lysine will be 9.7. Thank you. If you like the video useful, kindly like it and subscribe it.